good morning, all the students and all the participants from DGMs, also from OMC and for the other organization who are just joining. So there are so many participants from students, research scholars, MSc and BSc students. Actually, the topic we will cover today will be your border planning in mineral exploration, and second one is mining methodology. Border planning, mineral exploration is the actual after prospecting, we have to explore minerals. So this is definitely, as I told, this is a professional domain. But you should know what we are doing in exploration after prospecting or something else, because you have to come to this area. If somebody wants to join, then it will be beneficial for them. So am I audible, Arindam? Arindam? Yeah. Okay. So anybody wants to ask any question, you can stop me in between. You just put your mic on and just ask me question. Otherwise, you can put your questions in the chat box, and I will definitely answer all the questions after completion of my PPT first part, and we'll get. There will be some gap, 5 minutes if you want. Then we'll start the second part. First, we will concentrate on boreal planning in mineral exploration. So what is mineral exploration? It is the source of mineral deposits. So in order to make a call it a deposit, we have to first make the prospecting where we should search for the minerals, which terrain we should search the minerals. It will come definitely from your mining, so your mapping projects or some geochemical mapping, your geophysical mapping and geological mapping. Then we'll just squeeze our area to a particular domain that here we can search for the different minerals, and from the basic data, from the recognized survey, from the preliminary data, we should definitely know what is the value we are getting in that area, and if it is prosper for your future mineral exploration, then we'll go for it. So all the mine you are now seeing in the world or in India, in Odisha, in every part of your India, that starts from an exploration project. All exploration projects will not lead to your mines, because some are not encouraging, and in the latter stage it is found that it is not encouraging, values are coming in the depth, or the mine will not sustain for a long time. That's why every exploration project will not lead to become a mine. But a mine has, in the preliminary part, it was an exploration project only. The purpose of exploration is to locate new source of metal or useful minerals. Rapid depletion of surface and shallow surface deposits warrants adoption of modern techniques. So definitely, because in previous days, in 2007, 2008, what I can recall, in chromite, we just consider the percentage of 30% chromite is minimal for the marketing. But nowadays, even less than 10% chromite, we are searching for it from the top. So it is due to the development of the technology that we should extract this 10% chromite from the ores. So what is a mineral resource? It is a concentration of concentration or occurrence of material of interesting economic interest, something having some economic interest in or on Earth's crust in such form, quality, quantity that are reasonable prospects existing for eventual economic extraction. If the resources, so there is a difference between resources and reserves. Resources, if it is economical, then it called a reserve. Resources means you have to explore for some project, and you get this type of million ton your mineral or metal is there and having some cut-off grade. So if that cut-off grade is mineable, or its cut-off grade can meet your mining expenses, and if it is a beneficial project, then we can call it a reserve. If it is economical and it is feasible also, there may be economical value, there may be high grade value, but if it is not feasible, we can go to there. Our extraction cost will be more than the market cost. Then that project will not call a economical prospect, economical mining. So that's why resources having good economic value and also a feasible project, that we can call it a mineral reserve. So now there are different countries there in the world, and they have different system of classifying their mineral objects. So before we go to overall planning, we should know what is UNFC. UNFC is your United Nations Framework Classification. This is the platform where all the countries are classifying their mineral deposits into a common economic platform. That's how if there is a forum, then they can judge which economic value that project is uh, assigned by that country, and they are just classifying. It is widespread in all over the world, and most of countries are now accepting this UNFC classification. There are certain other classifications also. I will tell you in the last slide that which classifications are now considering in different countries. Yeah. What is telling?
Your voice is not clear, sir.
Voice is not clear. I think.
No, sir. It is.
No, because nobody is telling. That's why you may check your network connection. I think we have a good internet connection. Arinamda, voice is clear now? Yeah. So on. Yeah, now it's okay. Anybody can chat me that whether my voice is clear or not.
Now it is okay, sir. Thank you.
Yeah. So on international forum, all the mineral deposits now are being classified as a UNFC platform. So that is, this the main objective is to bring all the classifications of different countries to a common platform, common international platform. So it started in 1992, having started development system only. Then in 1997, UNFC for solid fuels and minerals commodities that published. In 2004, UNFC extends to cover oil, natural gas, and uranium. 7-8 mapping revision simplification of UNFC 2004 issued some public comment because they want that it should be adopted worldwide. That's why they seek for the public comment. Then 2009, UNFC 2009 approved, published in 2010. In 2010, now UNFC development is going on to include different minerals, and they are changing their norms by some feedbacks from different countries. So terms of ore resource classification. So we have to classify the ores. What is a mineral occurrence? The mineral occurrence is an indication of mineralization that is worthy for further investigation. Does not imply any measure or volume tonnage and is not a part of mineral resource. But occurrence, we have there is mineral occurrence. We have some background value. We have some values we got from your chemical analysis, from geophysical signature like that. So we can tell that the mineral occurrence is there, and we have to go for the further exploration. So what is a deposit? A natural concentration of mineral or aggregate of minerals which has been adequately investigated and is either under exploitation or has been found to be commercially significant for exploitation presently or in foreseeable future. Suppose a deposit, you have to calculate. There we are doing it different stages. I will come in later slides. The G4, G3, G2, G1 stages. So in deposit, we have to just calculate the grade and the tonnage of the ore or mineral or metal, whatever it may be. That it can be profitably extractable, not in now, but can be exploited in the future also. That may be called as a deposit. The resource, I have already told you, it is a quantifiable concentration of naturally occurring solid, liquid, or gaseous material on earth source, having some economic value. Commercial extraction can be possible in now or in the future. Then what is reserve? If a resource is economically viable and also feasible to be extracted from the as part of mine, then it is called a mineral reserve. So in UNFC 1997, we are just using three axes. Your is economic axis, then feasibility axis, and the geological axis. Economic axis, feasibility axis, and geological axis, EFG. Now these are the three-dimensional form. This is the geological axis. Here it is G4, the Economic survey. What is the preliminary one? Then it is the prospecting in G3, then general exploration in G2, and detailed exploration in G1. These all the exploration are about the increase in your database and your confidence. Because here you can see in borel planning we can make a scout borel, then there is some specified borel spacing in G3, and again it is reduced in G2 and again in G1. So in G1 we have already, if it is geological axis, here you can see it is 331. One means geological axis 1 means you have already proved that there is some reserve, some resources there, and it is proved already. We cannot deviate from that one. Now we can study the feasibility. If it is feasible or not, then the economical concept will be there, and all the domain of that is your mining engineering, your economical engineer, economic professionals, they will come into the picture. So 111 is the proved mineral reserve, and 121, 122 is the probable mineral reserve. Now, previously it was, if it is 111, then it will be it would have been auctioned in the past cases. But now, if we have a G2 exploration report having good feasibility, pre-feasibility report having good economical value, then we can go for also mining. The rules are now changing from day by day. So total code will be this. This is 4, this is 3, and this is 3. Total is 36. And the most proved mineral reserve is 111. That is your, it is economical, it is feasible, and it is geological access. We have at the detailed exploration stage. And list is your 334. That means the no feasibility study has been done, and 3, it is not also economical prospect. It was not already been built with, and in geological axis it is only recognized stage. So I have already the total resources is equal to reserve plus remaining resources. Okay. Then it is a 3-digit system. You can see here E3, E2, and E1. This is intrinsically economic, then potentially economic, then economic. And in feasibility also, this is F3, F2, and F1. This is increasing their order. And in geological assessment, this is recognition, preliminary exploration, general exploration, and detailed exploration. So we'll deal with geological axis because we are geological from geology domain. So that feasibility study, that will be by the environment person, professional, by economic professional, and some other professionals. Though we are, our work is to do this geological prospecting. That is your recognized survey, your preliminary exploration, and general exploration, and detailed exploration. So each stage generate resource data with a clearly defined degree of geological assurance. That I already told you that we have to increase our confidence. That this is in recognized survey we have to deal with the broad area. Then in preliminary we have to squeeze out gradually up to G1 stage. That we have to define the block boundary, define the mineral length and width of the mineral zone, like that. Then what are the field guidelines for this borals and others in UNFC? They categorized in different ore minerals in different deposit type or deposit habit. That is your bedded stratiform tabular deposit, in which the principal kind of minerals are your iron ore, manganese ore, bauxite, limestone, chromite, like that. Similarly, in the lenticular bodies of all dimensions, including all your veins, lenses, pockets, and irregular shape. These are iron ores, manganese, and your base metals, copper, lead, and zinc, scan bodies, like that. Then gemstone and float of placer deposits. So now the exploration techniques, UNFC has classified that for mapping in G4, we have to cover it in 1:50,000 scale or smaller scale. In G3, then it will our area will be in the large scale, that is 1:25,000 to 1:10,000. In G2, it is 1:5,000 to 4,000, or in G1, 1:2,000, or even larger scale, even 1:500 scale also permissible. Similarly, in geophysical, we have to ground geophysical survey of the whole area. In G4, in the present practice we are adopting in GSI, we will take around 100 square kilometer of area. So ground geology survey is necessary of the whole area in order to define where geophysical signature of minerals are there. And then this ground geophysical survey will again switch to the G3, detailed geophysical survey and borehole geophysical logging. Then in G2, borehole geophysical logging, also G1 borehole. Because these in G4 we have to do only ground geophysical. But in subsurface we don't know. That's why when you put borehole, we can put also borehole in G4. We can also make it blocked by geophysical people. And in G3 but it is most, and G2 it is definitely there, and we have to know the subsurface signatures of different minerals. If we sometimes we just miss the uh, uh, signature that, and we can definitely prove it by the geophysical signature, that if that same signature is coming from the mineralized zone and the same signature we are missing out in the other part of the border, then we can definitely search for that one and we will chemically sampled and analyzed to get the actual result. Why these signatures are there? Similar signatures in different part of border can be sampled and analyzed. That's why geophysical survey in boreholes is very much essential. Then geochemical, the graph chip sample, channel sample, soil sampling, pitting, trenching, etc. That is also done in G4, G3, G2, and G1. Sampling is the most in borehole cases. If you have a particular mineral zone in G4, you can also sample the whole borehole if you want, and if you are geologically confident that we can definitely get something by sampling this one, then we can go for that one, no problem. In G2, G3 and G2, you have strong specific, in G2 there is definitely specific mineralized zone is there, mineralized white, and your depth persistence will be there. Then you have to go for the sampling at that zone. In G1, definitely that is a grid pattern drilling and sampling will be more. Then in drilling, in G4, sorry. In drilling, the G for scout drilling if necessary. If you find it necessary, then you go for scout drilling. There is no space defined here, but if you where you can want to put the borehole, you can put it. But in G3, in limestone, bauxite, potash, salt beds, the grid spacing is 800 meter of closure of regular habit, and if it is irregular, then 400 meter can be done for borehole spacing. Just a minute. Sorry for the interpretation. For limestone, if limestone and bauxite, there are some flat beds there, and it is regular. You can you have a clear mind that it will go further 1 kilometer or further more than 1 kilometer. Then you can put the borehole up to 8 spacing with 800 meter. If it is a irregular habit and the extension of that your mineralization is not certain, then we can go for 400 meter in G3 stage. Others may be 400 meter or 200 meter as you obtain the mineralization habit of the mineralized zone in that area. In G2, this 800 meter again close to 400 meter, and in 400 meter it will again reduce to 200 meter. Similarly, other spacing may be 200 meter or less. G2 in cases of your copper, lead, and zinc, that is 100 meter. The borehole space in between 100 meter. It should not be 100 meter.
Hello, sir.
Yeah.
Actually, this is my question for the G1 and G2 and G3.
Mm-hmm.
In the diagram, 100 meters for limestone, so 200 meters for limestone and 400 meters for limestone. My mines area is the only 10 hectares. So how am I identify the G1, G2, G3 for grading for exploration?
It is 200 meter or closer for deposition of regular habit. I have written it should not be more than 200 meter. Right now? Here
Okay.
in G1 it is written 200 meter or closer. Everywhere the maximum limit is 200 meter. Similar in G2 the maximum limit is 400 meter. We cannot put borehole spacing more than that. Right now?
Okay, actually, I am repeated again. My my mines is 50 hectares area.
50 hectare.
50 hectare.
Yeah.
how to identify the exploration for G1, yeah, G2 and G3 for limestone?
G1, you are a mining company?
Yes.
Yeah. If mining, then you can put borehole by grid wise. Because if it is a regular habit, then there is no need to drilling in close spacing because it will waste your money. If you are certain that your limestone bed is extending for 500 meter or 200 meter or more than that, and you have a good report also, previous report, then why we will put these boreholes, 2, 3, 4 boreholes? That means your body is not regular. If it is regular, then you did not put these boreholes. It is just a wastage of money.
It is if the body is the regular, so you tell me I would G3 in exploration.
No. I am telling that if it is in G3, in limestone now your laws are being changing. If it is a bedded body, regular body, or in G3 stage also, and having in limestone and bauxite, they are going for the mining auction with a pre-feasibility study report, right? So
Okay.
now the scenario is changing. That why this is a idea of 1997 UNFC, and it is just modified in 2009. So now the rules are being changing. That if it is there, then why to put money on that? We could directly go for mining with a pre-feasibility study, and we know this is a regular body. So what we need not to stick to the rules, right now.
Okay. Okay. Thank you, sir. Thanks a lot.
Welcome. So we'll proceed further. Now, this is some pictures of your pitting. If you put pit here, then you have to sample all the horizons from the top to bottom in order to measure if there is some geochemical values are coming for the mineral bodies or something else. Somewhere in this area where picture is there is no such lithology. In the depth of 2 to 3 meters. So it is we are just taking the geochemical samples and to ascertain that whether any capillary action is there, whether any background value is there in the soil only. But here you can see these are the rocks are exposed. So we are just putting a trench along the strike of the mineralized zone, that how much white we are getting in that area to ascertain on the surface the width of the mineralized body. And that's why we are putting the trench. Here also the same trench is being done by the laborers. So this is for lenticular bodies of all dimensions, including bodies occurring at ancillary, silicified, linear zones, composite veins, lenses, pockets, stopwatch, etc. Scout drilling as it necessary, and borehole is 200 to 100 meter closure interval. It is a lenticular body, that's why. And G2 it is 100 to 50 meter, and G1 it is 50 to 25 meter or closure interval. It is depends upon the judicious utilization of your money and also your geological knowledge of the geologist. Then these are some gemstone rare pegmatite sea veins. These are some spaces we should consider for drilling, because it will be getting too late. I'm just going out. These are the drilling instruments. This is your drilling machine. We have to anchor it, put it in the right way, that in between that will not get tilted from its area. This is a torque mounted drill. For G2 and G1 stage of exploration, the depth content of the mineralization may be considered limited to the depth up to which direct evidence of mineralization is established. Definitely, anybody is going to G1 stage, and now in G1 stage it is doing by minor only. But in G2 stage, we'll go for the auction. In G1 stage, there is different levels. If it is underground level, underground mining or open cast mining, then they are putting some drill holes to ascertain the depth continuity of the mineralization zone as surface continuity, already from the previous reports. Then some petrographic and mineral study will be there. Then ball density study, bulk sampling for beneficiation study. This is for your mining people, because if you there is so many rocks are there, maybe 2-3 types of lithology is there. So and in that mineralized host rock of mineralization, what type of minerals are there, how we will extract that one, which techniques we have to adopt, that will definitely dealt with by the mining. That's why they require this bulk sampling or beneficiation studies, and we are just carrying out by IBM only in India for GSI. Then environment setting, that will be studied. So in UNFC 1997, 3 axes, that is your stages of geological assessment, stages of mineability assessment, that is feasibility, and degree of economic viability. But in 2009, in economic axis, one thing is added, that is your social viability. If it is not affecting any social issues or something else, then it will be called as economical, otherwise it will not be. Then we coming to borehole planning. As you already know, in UNFC, it is fixed that which minerals, which bodies, irregular habit, lenses, or something else. So we have to put the borehole according. The spacing of borehole will be like that. Then we have to go for the planning of the borehole. So this planning of borehole, that will be taking the gist of this remote sensing data, geochemistry data, geophysics data, and geology data. Will squeeze our area to the a particular length and width of particular length and width, and we have to apply this all the integrated studies, all the studies like your from signatures from remote sensing. In geochemistry, there may be some values of background values of different minerals or metals. Then some geophysical signatures, it may be superficial or maybe subsurface, because if in nowadays you go for GPR survey, ground radar penetration radar, then you can find also some depth persistence of what signatures you are getting on the surface. Then the geological data you got from the mining, your petrological studies, your again your sampling, like that. Then we have to delineate the ore body, that our ore body is going like this direction. It may be northeast, northwest, or maybe northeast, northern, or southwest, like that. So we have to delineate the ore body, the strike and the deep of the ore body, and its width, and if possible maximum depth persistence. In G4 stage, we can put different scout boreholes. Then we can know at least know up to this depth we are getting the signatures of the mineralization. Then we have to go for the borehole planning. Then drilling. After drilling, we will get the cores, and we have to make the core logging and sampling. Then make the chemical analysis of the sampling and get the results. After getting the results, we have to calculate the resource estimation. So how it project is developed, that is from geological. I have already discussed this one. Geological appraisal, then exploration, then resource estimation grade wise, feasibility study, mineability, beneficiation, metallurgy, then business value of that metal or mineral, and then reserve, that's resource estimation according to UNFC codes. Then mining report. This is the report where we will go for the auctioning. Then investment decision. Classification, I've already told you, that's the economic axis, feasibility axis, and geological axis. The 1, 2, 3, 1, 2, 3. This is degree of 1 is the highest degree, 3 is the lowest degree. And in geology case, that is 4, 3, 2, 1, G4, G3, G2, G1. Recognize survey, prospecting, then general exploration, then detailed exploration. Now here we can see, I have already told you in that area, in that previous slide, that for different deposits, our spacing of the boreholes will be different. So here you can see in G4, that will be widespread. 5 boreholes per 100 square kilometer for this is salt, potash, iron, manganese, limestone, bauxite, chromite, and barite. There is some actually it is going up or off. For salt and potash in G3, it will be 50 to 100 meters spaced, and like your iron, manganese, then 200 to 400, then limestone 400 500, like that. This is just I think it is zigzagged in this slide. I think there is some problem. Then borehole planning. Based on data marked on the detailed geological map depicting lithology, structure, attitudes, mineralized zones, wall workings, we have to delineate the first body of the mineralized zone. The strike length on the surface, the width, and its depth, where up to which depth it may go. Then different intersection drawings will be there. If we put borrow like in this angle, then how in which depth we will encounter the mineralized zone, like that. Then drilling and drill core study of lithology, then study of structure, mineralization pattern, nature of controls from the core, from the drill core. Then borehole geophysics and geophysical logging. Along the borehole, we'll put the geophysical instruments down to the borehole and get the geophysical signatures of different lithologies or different horizons encountered along the borehole. Then borehole planning various ore deposits. If it is simple, homogeneous in extent with horizontal to sub-horizontal deep, then you can put the vertical borehole. Put maybe your 100 to 200 meter or 200 to 200 meter pattern, like what mineral you are encountering and what is the nature of that mineralized zone. Then you have to decide which pattern you will follow in that area. If it is deformed, then few boreholes planned in major mineralized zone body to interest the ore zone. Add up pinting touching may be there, then shallow borehole to know the geometry of the ore body. Then if it is steeply dipping a borehole bodies, then borehole plant inclined and a series of boreholes will be done in that area to know the strike continuity and the depth persistence. Then we have to do the core sampling, then assaying, then delineation of ore zones based on cut-off grade and stopping wide, vein site, like that. This is a resource estimation part. Then testing of physical characteristics, then petrological test and reservoir estimation of the mineral deposits. So if it is a flat body and having the deep is very minimal or less than 5 to 10 degree, 5 degree or 10 degree or maybe maximum 15 degree, then we can go for this borehole, your flat your vertical boreholes. You can put it by a grid pattern or whatever you choose it fit for that area. This is based on the geological knowledge only, and the geologist is the best judge to decide the which borehole or which pattern he will follow in that area. General principles for inclined borehole, that is bearing and azimuth of the borehole should be perpendicular to the ore body. Minimum length of borehole correct should be there, and correct the picture of width of the ore body from top to bottom. Then borehole located on the hanging wall side of the ore body, definitely where the deep is there. If there is a deep, there is a suppose a deep is there, then you can consider this is the foot wall, this is the hanging wall. Upper side of the deep, it is a hanging wall, and the below is your foot wall. So your borehole, if it is a dipping body, then your borehole should be here in the hanging wall, and it will intersect the foot wall. Inclined ore body angle should be 45 to 60. It is the ideal angle. Then fall, fracture zones, mines, dumps, old workings should be avoided. Because in that area, your water loss will be more. Your drilling machine will be face difficult to drill that zone, and maybe driller may be broken due to the your fractures and joints also. Then area that available water should be there for cutting the boreholes, and cutting large thickness of hard rock should be avoided, because if there is a quartz reef and it is around 10 meter to 20 meter, then definitely we will not go for any fruitful drilling techniques. Then azimuth zenith perpendicular strike of it. Here you can see the borehole is dipping like that. Suppose this is 45 and you are putting the borehole also in 45, then you will encounter this zone. It is the true thickness of the mineralized zone, because if it is 45 and this is 45, then it will be 90. So you are cutting this mineralized zone at the angle of 90 degree. That means you are cutting the true thickness. So we have to, every time at the end of the show, we have to calculate the true thickness. You have to calculate the resource. For resource, you have to calculate the volume first. For the volume, you have to calculate area and into your thickness of the ore body. So that's why your true thickness is needed in case of your cross section method where you will calculate the resource, and for your LV section, longitudinal vertical section, then you have to consider for the
Hello, sir.
thickness.
Excuse me, sir.
Huh.
Sir, what if my ore body is dipping 65 degree? Can we drill borehole at 25 degree?
I am coming. Just a minute. I
Yes,
am coming
yes.
to the next slide. This is for the azimuth perpendicular to strike of the deep plane. Right now.
Okay,
This
sir.
is the ideal case I am telling about. This is ideal case if your ore body is dipping 45 and you are giving the borehole 45, then it's okay. If your ore body is dipping 30 and you are giving a borehole in 60, then also you will encounter other 90 degree. Like
Yes.
this one. If your borehole, your mineral zone is cutting and the dipping of the borehole is large.
More than 65.
Steeply dipping.
Yes.
Like in
Yes.
that case, you can put borehole in between 45 to 60. 45 to 60 is ideal case. Because after 60, then there will be much deviation in the borehole. So that's why we are putting 45 to 60 degree as a ideal case. So if you are putting this one, then you have to calculate this true thickness. Okay. So this is your apparent thickness. This your angle is the core axis angle. This is the angle between your core, the borehole and the core body. Okay. If you see the different bedding planes, and if you have already seen a core, then that bedding place you just put a line here, and you just measure the acute angle of that borehole on that core surface. Then you will find this alpha. This is the core axis. Okay, this is angle at which your borehole is cutting the mineralized zone. Do you understand?
Excuse me, sir. सर हिंदी में बोल सकता हूँ क्या?
हाँ.
सर एक्चुअली यहाँ पे तो हम लोग जो ड्रिल कर रहे हैं यहाँ पे भी सर हमको ट्रू थिकनेस नहीं मिल रहा है, तो हम लोग वर्टिकल बोरहोल देने से भी सर प्रॉब्लम क्या होगा? वर्टिकल बोरहोल में भी तो हम लोग ऐसे कैलकुलेट कर सकते हैं या प्रॉब्लम?
जस्ट अ मिनट, ये आप जो वर्टिकल बोरहोल देंगे, आप यहाँ से यहाँ पे वर्टिकल बोरहोल दे सकते हैं, ठीक है, लेकिन वर्टिकल बोरहोल देने से आपका डेविएशन कितना होगा आपको पता नहीं। वर्टिकल बोरहोल सपोज आपका मिनरलाइजेशन जोन यहाँ से आपने दे दिया, तो यहाँ पे कट कर गया, आपने यहाँ से दिया, यहाँ कट कर गया, तो आप कितना वर्टिकल बोरहोल इसको एक्सटेंड करने के लिए देंगे? क्योंकि आपका डिपिंग है, ठीक है ना। अगर आप कहीं से मिनरलाइजेशन चेंज कर दिया, मतलब इस साइड में आ गया, कभी इंटरप्रिटेशन गलत भी हो सकता है, तो आप पूरा तो मिस ही कर गए पूरा।
यस,
तो हो सकता है कि आपके ये मिनरल जोन आपका नोन है, हो सकता है कि यहाँ पे भी आपका कोई मिनरल जोन हो, राइट, हो सकता है यहाँ पे कुछ हो। तो अगर आप क्या करेंगे, इंक्लाइन बोरहोल में आपको अगर आप वर्टिकल देते जाएंगे, देन यू विल मिस द मिनरल जोन, राइट ना, एंड यू विल एनकाउंटर मिनरल जोन अप टू मैक्सिमम लिमिट। सपोज यहाँ से आपने शुरू किया यहाँ तक, तो आपका एरर कितना आएगा, राइट। सो दैट्स व्हाई ये आपको क्या करना है, आपको 90 डिग्री में काटना है। मेरा एम वही है, जिसमें नहीं हो पा रहा है मैं उसमें दे रहा हूँ कि एंगल करके इसको बोरहोल करना है, और जितना मिनिमम हमारा हो सकता है कि एरर वो इतना अच्छा ही है हमारे लिए, ठीक है ना।
मींस मतलब अगर डीप बॉडी ज्यादा डीप है, स्टीप डीप है, तो हम लोग 60 में ही ड्रिलिंग करना वाइज रहेगा या 60
वाइज रहेगा? 60 आगे जाएंगे, हो सकता है आप 60 से ऊपर दे दिए, सब 65 में दे दिए। जब ये मिनरलाइज को कट किया, हो सकता है ये एक मीडियम है और ये एक मीडियम है, ठीक है। यहाँ से यहाँ जाने में लिए आपका हो सकता है बोरहोल ऐसे मुड़ जाए के कारण, नहीं तो वो ऐसे भी आ सकता है, ठीक है। तो 45 से 60 देने में ना वो ठीक से काटता है, और डेविएशन मच नहीं ज्यादा नहीं होता, जो आपका हाइड्रोफ्लोरिक फ्लूइड देके हम अभी मेजर करते हैं हर 50 मीटर में आज की डेट में, और इवन आप बोरहोल कैमरा भी यूज कर सकते हैं। तो इसमें ज्यादा डेविएशन हो गया तो आपके लिए तो पोजीशन हो जाएगा, क्योंकि ये तो एक बोरहोल यहाँ के यहाँ चला जाएगा। एक बात ऐसे भी हुआ है, बोरहोल यहाँ से शुरू होकर यहाँ जाके फिर यहाँ निकल गया, समझ गए ना। तो ऐसा करना नहीं है, ज्यादा एंगल देने से आप सपोज आप 30 से नीचे देंगे तो हो सकता है बोरहोल ऐसे जाके ऐसे निकल जाए, राइट। तो इसलिए डेविएशन को रोकने के लिए तो वी हैव टू अडॉप्ट दैट 45 to 60 इज आवर आइडियल एंगल, वी हैव टू गिव इट, राइट ना सर। Okay, so this is a case where you can calculate this alpha, then you can calculate true thickness is equal to Ti sin alpha, because alpha, this is P and this is your H, then P by H is equal to sin alpha, then you can calculate true thickness, right? So here you can see in the plan, here is your mineralized zone and here is your borehole. So we can So as it is dipping here, so we can give this, but here you can see here is 70 and we are giving as 45. We have to calculate this. We are getting this apparent thickness, and then from apparent thickness by taking the boral axis angle, boral axis angle, the angle made by this your boral and your pore body. Then we can calculate the true thickness. For calculation, it is a pictorial only. This is a boral, this is theta as your boral, this is your boral angle, this is beta, this is your mineralization angle. Then you have to calculate this horizontal thickness if you are calculating your resource estimation through LV section. And for cross section, you have to calculate this T. There is two thickness. For two thickness, it is S sin alpha. This S is your boral. This is apparent depth you are cutting along the mineralized zone. Core axis angle, right? Then your ST you can also calculate. It is T by sin. Separate issue. So here you can see this is different lithologies, and we are putting borals like that. We are first intersecting this mineralized zone here, then here, then here, and this zone is given because we have to take if you have to calculate the resource, then you have to take the half part of this one as the area, then for this boral, and half part of this area for this boral. This is a zone we are considering for this boral, and for the BS3 we are considering this zone for resource estimation. Then fixing of borals on the ground. The proposed boral axis is fixed on the ground from the triangular point. Here, if it is a point, then here is your machine tripod. You can take it from your surveyor will do that, and the point is there, and this is the pegs from different directions. The directions you have to give to the surveyor, and surveyor will definitely by their compass and others they will fix the boral direction, in which direction it will go. Then core keeping after boral is completed, also in between the boral, then we have to keep that core because it is very precious. We are incurring so much of money, then we have to preserve it for our future reference or for our present purpose also. So this core keeping are now we are in previous days it was done through by your wooden boxes, but now it is GI boxes or galvanized boxes. It is to preserve the core a long time. So these are two types of core keeping we are following, that is book pattern and serpentine or snake pattern. Book pattern, this is your book pattern that you start from this one, again this one, again you start from this one and come to this end. This is the book pattern. But in serpentine pattern, you have to follow from this side or from this side. This one you have to go this side, again from this side, again this side. This is snake pattern. This you can see here. This is snake only. Suppose you are going this one, then this one, again this one, like that. You have to keep the course. This is snake pattern and this is book pattern. In book pattern, it is individual pattern. One finished here, then you start from other initial end again. But in snake pattern, you have to follow the line. You know what is core logging? Because it has to preserve the data of the core, which lithology it is, which structures, microstructure you are observing in that data, in that core, and if there is mineralization, what is your I value, what is your visual estimation V, and which minerals you are encountering. If in case of your copper, if it is your chalcopyrite or azurite or bornite, if it is iron, then whether it is hematite or magnetite, or in any case, so which ores you are encountering, you have to get a record of it by centimeter by centimeter. You have to describe the core, or maybe from your RON, by RON wise also you can make it, or if it is details you have to make it very detailed, and if it is very prospective zone, then you have to go for 1 meter or maybe 50 centimeter or even 25 centimeter detail core logging. Okay, percentage of core recovery should be there. What is the grain size, the recognized minerals, everything has to be recorded. type of degree of alteration, then angle between your structural planes, your core axis, like that. Everything should be entered, because after you doing this one, then on that record only you have to calculate your angle. Your resource estimation will be there. If anybody will see through the report, then he has to see the core logging first, which lithology they are encountering, which type of minerals are there, which type of structures are there. So this will definitely put value on your report. And this is a common sheet for your core logging. Then we can see from which meter depth to which depth, then run length, then core length of core recovered percentage, loss of core, then lithology, then remarks. It is you can also modify by your own. So these are some classifications adopted different countries. I told you in the earlier stage that from Australia it is JORC, in Brazil it is CBRR, then USA SME, Chile and Peru CMC, then Colombia CCRR, then Europe and UK PORC PRC, like that. Thank you. This is all about your borehole planning on UNFC. Now, if
हेलो सर।
okay.
सर मेरा एक डाउट था सर, जैसे कि हम लोगों ने एक एरिया में 4 या 5 स्काउट बोरहोल दिए,
राइट,
तो उसमें से 2 मतलब सपोज 2 नेगेटिव आए, 3 पॉजिटिव आए, ओवरऑल एरिया प्रोस्पेक्टिव है, तो हम किस बोरहोल से उसको मतलब बोरहोल प्लान शुरू करेंगे? और ये जरूरी है क्या, मतलब जो तीनों बोरहोल पॉजिटिव आए हैं, अगर हम ग्रिड पैटर्न में ड्रिलिंग करेंगे बाद में उसको G2 में लेके या G3 में लेके G2 में लेके, तो उसको कैसे प्लानिंग करेंगे बोरहोल प्लान?
देखिए, पहले तो आप कैसे, आपका मैप कैसा है पहले वो देखना है। अगर मैप आपका जो 3 बोरहोल है आपका कंटिन्यूअस है, या जो आपका जो
रैंडमली है सर, मतलब डिफरेंट ओरिएंटेशन, डिफरेंट लोकेशन में
नो
है।
प्रॉब्लम। तो आप जो एरिया है ना, आप उसको पहले डिफाइन कीजिए कौन से बोरहोल को आपको, सपोज आपका 4 बोरहोल है, 4 बोरहोल से आपके लाइन में डाला या डिफरेंट साइड में डाला है, ठीक है ना
सर?
तो जहाँ पे डाला है आपका 3 बोरहोल आया, तो 3 बोरहोल मीन्स यू हैव ए गुड प्रॉस्पेक्ट एरिया, right? You can go for the further exploration. So you define your G3. G3 means you have to आपको उसको क्या करना है, थोड़ा स्क्वीज करना है। और डिफरेंट, सपोज आपने पहले 500 मीटर में किया था या 400 मीटर में किया था G4 में।
अच्छा, पहले से रैंडमली किया था, मतलब डिफरेंट विद इन द एरिया, डिफरेंट एरिया।
आपका तो एरिया कुछ होगा, एरिया तो सपोज 100 स्क्वायर मीटर हो सकता है, उससे तो ज्यादा नहीं। आप पूरा तो टॉपोसिट नहीं करेंगे, तो आपका जो 100 स्क्वायर मीटर है ना, उसमें आप कम से कम 400 मीटर में कर सकते हैं। अगर कौन सा ये मिनरल है वो भी तो देखना है, ठीक। फिर नहीं तो आपको पीटिंग ट्रेचिंग पे ज्यादा ध्यान देना पड़ेगा। साइमल्टेनियसली आपको जो जियोकेमिकल का जो सॉइल सैंपल भी लेना पड़ेगा आपको। अगर वहां पे कोई लिथोलॉजी है तो उसका चैनल ग्राफ सैंपलिंग कलेक्ट कीजिए सरफेस में, एंड उसके बाद बोरहोल कीजिए। बोरहोल तो ऐसे आप नहीं किए होंगे, कहीं तो पहले सरफेस सिग्नेचर देखा होगा फिर बोरहोल आपने पुट किया होगा, राइट। ऐसे G4 में तो आप कहीं पे करेंगे तो आपका पैसे वेस्ट है, ठीक है ना। तो आपको पहले तो सरफेस का कुछ डाटा तो आपके पास होगा, और सरफेस का डाटा एंड बोरहोल का डाटा लेके पहले आप डिफाइन कीजिए आपका जोन। हाँ, इस जोन में मेरा मिनरलाइज जोन है, तो इस जोन को मुझे करना है। तो उसके बाद आप उसका स्विच कीजिए, बोरहोल का जो है प्रॉपर ग्रिड पैटर्न में कीजिए, प्रॉपर जो आपका स्पेसिंग देके कीजिए, जैसे 200 मीटर हुआ, 400